RAG, Retrieval Augmented Generation, is a framework designed to improve the accuracy and relevance of responses generated by large language models, LLMs. Let's take an example. Imagine you're using an e-commerce website to shop for products. You want to ask the site's chatbot a question about a specific product. However, if the chatbot is powered only by a general-purpose LLM, it may not be able to answer your question correctly because the model was trained on generic data and doesn't have access to the website's specific product details. There are a couple of ways to solve this. Fine-tuning. This means retraining the model with the e-commerce product data so it can answer domain-specific questions. But if the product catalog changes frequently, this approach becomes inefficient. You'd need to retrain the model every time the data updates. RAG, Retrieval Augmented Generation. Instead of retraining the model, RAG connects the LLM to the e-commerce website's knowledge base, such as FAQs, product specs, and policies. When a user asks a question, the system retrieves relevant information from the knowledge base and feeds it to the LLM. This enables the LLM to generate accurate and context-aware responses, even without being fine-tuned. How RAG works. Input prompt. The user provides a query. For example, what is the return policy for electronics on this site? Step 1. Retrieval. The input prompt is first sent to a retriever module. This retriever searches through the e-commerce knowledge base, documents, FAQs, manuals, policy pages, etc. Using either traditional keyword search like BM25 or dense vector search using sentence embeddings and vector databases like PySys, Pinecone, etc. It returns the top KK most relevant documents or passages that may contain useful information. The step 2. Augmentation. These retrieved documents are passed along with the original user query to the generator. This step is where the magic happens. It's no longer just generating from memory, like traditional LLMs, but it is now grounded with the latest or external information. Part 4. Step 3. Generation. A pre-trained language model, like GPT, BART, or Llama, takes this enriched context and generates a response. The response is now much more accurate, specific, and aligned with the actual content of the knowledge base. Why not just fine-tune? Fine-tuning is expensive, time-consuming, and hard to maintain. If the product catalog or policies change frequently, retraining the model again and again is not practical. RAG solves this by decoupling the knowledge base from the model. It keeps the knowledge external and updatable without changing the LLM itself. Benefits of RAG: up-to-date answers without training again. Hallucinations are reduced since responses are grounded in real documents.